Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is IGCSE physics, the extended physics, and we are attempting today's paper 4, and we have selected a question from October-November 2023 4-1 paper. This paper 4 belongs from the zone 1. We have selected its question number 10, and that question is related with the space physics. We are collecting the questions about the space physics for our O levels students. So let's start today's question. For the question number 10 of 2023 October November 4-1 paper is showing up. This question is related with the space physics. The Milky Way is one of many billions of galaxies. Each galaxy contains many billions of stable stars. Question number 10, it's A part. Stable stars transfer energy into space by emitting electromagnetic radiation from their surface. Describe what happens in the core of a stable star to release energy that is eventually transferred into space. So what happens in the core of the stable star? You see, in the core of the stable star, we have hydrogen and nuclei, and we can say hydrogen atoms. And what happens? They come close to each other. So two hydrogen atoms, when they come close to each other, what happens? Their nuclei, those atoms, they fuse into each other and they make helium nucleus, or you can say they make helium atoms. This process is called nuclear fusion. And due to this process, enormous amount of energy is given out. Let me show you my written answer. In the core of star, hydrogen atoms come close to each other and they fuse into each other and they make helium atoms. Due to this fusion process, enormous amount of energy is given out. Let's have a look at the marking scheme. Hydrogen nuclei fuse to become helium nuclei, nuclear reaction or nuclear fusion, hydrogen fuses into helium. So this was a 3 marks part. So question number 10, and it's B part. On the Earth, light from a distant galaxy is observed and analyzed by astronomers. This information is used to determine the speed at which the galaxy is moving away from Earth. Describe how the observed light is different from when it was emitted. So when we observe the light which is coming from a distant galaxy on Earth, that light has less frequency as compared to the light when it was emitted from the galaxy. And the wavelength of this light, which reaches the Earth from the distant galaxy, is more than the wavelength of the light when it was emitted from the galaxy. So we see a red shift in the light. Redshift means the light which reaches the Earth, its wavelength is larger and its frequency is less as compared to the light when it was actually originally emitted from that galaxy. So it's a 2 marks question. Let me show you my answer. Question number 10b, first part. When light from a distant galaxy reaches on the Earth, frequency of this light becomes less than the frequency of light when it was emitted. Its wavelength becomes larger as compared to its wavelength when it was emitted from distant galaxy. So redshift is observed in that light which is coming from the distant galaxy. So let's have a look at the marking scheme. It says observed wavelength is longer, wavelength is shifted towards the red end of the spectrum. Light from galaxy shifted towards the red end of the spectrum. Okay, so this was my answer. This was the marking scheme. Okay, so we are going to the question number 10. It's B, its second part. He says, state the quantity that astronomers use to determine the speed at which the galaxy is moving. So the astronomers basically they observe the change in the wavelength of the light. They observe the change in the wavelength of the light. They observe the redshift in the light reaching on the earth. They observe change in the wavelength due to redshift. So change in the wavelength or starlight due to the redshift. Okay. So then we have question number 10, and it's a C part, it's a numerical. The Hubble constant H naught is equals to 2.2 expo minus 18 per second. Calculate the distance from the Earth of a galaxy that is moving away at a speed of 1.3 expo 7 meter per second. So it's a very famous equation. H naught is equals to V by D. So we are going to use that and we are going to find out. Okay, so here on your screen, you can see, okay, H naught is the Hubble constant, that is 2.2 expo minus 18 second inverse. V is 1.3 expo 7 meter per second. D is the question. So H naught is equals to V by D. You have to remember this equation. H naught is equals to V by D, where V is the speed and D is the distance of that galaxy. So that D will become V divided by H naught. 1.3 expo 7 meter per second, and H naught is 2.2 expo minus 18 per second. And so when you divide them on your calculator, you get 5.9 expo 24 meter. 5.9 expo 24 meter. So this is the distance of that galaxy from the Earth. Our answer is right. Hopefully you understand. This is the solution. Don't forget this formula. Very, very important formula. Okay, so we are going to question number 10C, and its second part. He says, calculate an estimate for the age of the universe. Give your answer in years. So the age of the universe is 1 by H naught. You take simply the reciprocal of the Hubble constant, and but the value of the Hubble constant is per second. So when you reciprocate it, the age will become in seconds. But here he wants the answer in years. So we will convert that seconds into years. So let me show you how I have done this. So here we go. So age of the universe is equals to 1 by H naught. So it will be 1 divided by the value of the Hubble constant, that is 2.2 expo minus 18 per second. So your answer will be 4.545 expo 17 seconds. Now, because they want the answer in years, so I will convert this into years. And how I will do that? 4.545 expo 17 divided by, because in 1 year, there are 365 days, there are 24 hours in a day, and there are 3,600 seconds in an hour. So what we will do, we'll divide that number 4.545 expo 17 with 3,600. We will divide it with 24. We will divide it 365. So the answer will be 1.44 expo 10 years. 1.44 expo 10 years. 1.44 expo 10 years is the right answer, sir. So we are done with the question number 10. So hopefully you understand. So my dear students, today in this video, we have done question number 10, which was related with the space physics from October, November 2023, IGCSE physics, which we call extended physics. And we have done paper 4, and it's paper of the zone 1. And I'm making this video to provide the questions on the space physics for my O-levels students. I hope that this video will be helpful to you. If this video is helpful to you, please share the link of this video with your class fellows, with your teachers, and onto your social media accounts like WhatsApp, like Facebook, like TikTok, wherever, Instagram, wherever you can post it. When you do this, this helps me to promote my channel. Thank you very much, everyone. Have a good day, and God bless you all.